For the Forces concept builders that are going to be due this week. So we'll be working on those in class on March 30th. If you're absent or you need, pardon me, finish them outside of class, this should hopefully help you out. So remember, when you go to physics classroom at first, you need to click into your account. Then you're going to go and look and see what things are assigned. There should be 3 that are due tonight at midnight. And so those are the ones you'd work on. Don't look at the ones that are older than that. The first task is going to be balanced and unbalanced forces. I'm asking you to complete the wizard level and, the master level and the wizard level. You do not need to do the apprentice level. But if you do, it could help you out, like, to understand things. I think the apprentice level is very easy. So we're going to go ahead and start. So I'll do a couple in the master level, and then we'll do a couple in the wizard level. So the diagram below represents the forces acting on the leftward moving object. Each arrow represents a force. The length of the arrow represents the strength of the force. So is this object speeding up, slowing down, or constant speed? So in this case, it's definitely not a constant speed. I don't know. It's unbalanced forces, but it says, if I go back here and read, it's a leftward moving object. So that's what I have to read to figure out whether it's speeding up or slowing down. So if it's a leftward moving object and there's an unbalanced force to the right, that means it's slowing down and unbalanced. Remember, if you get one wrong, you may have to end up going and doing similar ones twice. So this is a leftward moving object. Consider positive direction to be to the right. So this is a position time graph. We've looked at these before. It's getting steeper and steeper. That means it's moving faster and faster in the negative direction. So the steeper means it's speeding up, and therefore if it's changing, you can have unbalanced forces. So I'm going to check that. If, say, you get something wrong, so this is like a motion map. So I think it's speeding up, so I'm going to say slowing down, and unbalanced forces, it should be speeding up, I think, in unbalanced forces, and it's like, oh, drats. So now that's red, and remember, you've got to do that twice. Remember, if you need help me, that takes you to certain parts, both the fundamentals about the question, about this couple versions of the question. You could close the window, you could add different things, like it'll take you to certain things about physics classroom. So I'm going to go back to the main menu. You do not want to go back before you finish a level, by the way. So in this case, again, there's just 12 different scenarios. This is a position time graph. It says it's moving rightward. So if the position is changing at the same rate, that's a constant speed, always balanced forces. Speeding up or slowing down, always unbalanced forces. So here I've got an unbalanced force to the left. This is a leftward moving object, so if I have a force to the left and it's already moving to the left, that better be speeding up. So there's lots of them kind of like that. The second, so remember, all you need to do are the master level and the wizard level. The next one is force and motion. So for force and motion, I'm going to ask you to do all 3 levels. So there's vertical motion only, horizontal motion only, and horizontal and vertical motions. So I'll do at least one from each of these. So here, an object is experiencing forces as shown. Each object represents the force in the specified direction. The length of the arrow represents the strength of the force. Which dot diagram represents a possible state of motion for the object? Select all that apply, so there could be more than one. So it does not say whether or not this is moving to the left or the right. So I have an unbalanced force to the right, so if it's moving to the right, those should be getting further apart. If it's moving to the left, those should be getting closer together. So I think those are reasonable. So I'm not sure if all these are dot diagrams or not. So here I have balanced forces. So that could either be something at rest, could be something moving at a constant speed to the right, could be something moving at a constant speed to the left. Okay, so I'll go back to the main menu. We'll look at vertical ones. Yes, I want to return. So here, it's an object with an unbalanced force downward. So again, we don't know the direction it's moving. It's not going to be either any of these three because those show constant motion, which would mean balanced forces. If it's moving down, the arrows are going to get further apart. If it's moving up, the dots, are going to get closer together. So notice whether you're moving one way or another, the pattern of dots is the same. Because if you're moving upward and you have a downward force, you're going to move slower and slower. If you're moving downward and have a downward force, you're going to move faster and faster. The last one here, both horizontal and vertical. So it seems like this isn't both in the same one, it's just kind of repeating them. So here I have an unbalanced force to the left. If it's moving to the left, they'd be getting further and further apart. If it's moving to the right, that means with a force to the left, they'd be getting closer and closer together. So yeah, this is just kind of a combination of the other two levels. Okay, so again, I would like you to do all three levels of these. It gets you good practice. This last one is which one doesn't belong for force and motion. For this one, apprentice level only, master level only, wizard level only get you different levels of points. You do all three levels, you get all the points. So we'll do one from each level. So here, one of these representations is not like the other. Tap on the one that doesn't belong. So this shows balance forces. That shows no change in position. That shows a constant velocity. And this shows an object moving with a constant velocity. So this is pretty sneaky. This could be moving with a constant velocity or at rest. So that doesn't really help. But this is definitely a constant velocity, and this says constant velocity. So this one, where I've got no velocity, does not agree with the others. We're going to go back to the main menu. We'll do one from the master level. So here, one of these is not like the others. So this shows an unbalanced force to the right. So if I have an unbalanced force to the right, I could be moving to the left and slowing down. So that could agree. This disagrees with those two because this shows a negative velocity, which is moving to the left, but it shows it getting faster and faster because it's moving away from zero. This shows a negative velocity because I have a negative slope on my position time graph, and it does show it going slower and slower because it gets flatter and flatter. So I think this is the one that does not agree. This is sneaky though, because it's a force to the right, but all the other three of these show motion to the left. So I'm going to pick one here. I'm not sure. I think this is one that would be incorrect answer. Oh, drats. And again, then you'd have to repeat that, something like that twice. Remember, again, help menu. You go to how to think about this particular question. There's a couple versions of it. Dot diagrams, position time graph, velocity time graphs. It tells you a lot about that. You can look at more or less of that. And this also goes to where you can look in and reread if you're not sure about some of those representations. So I'm going to go back to the main menu. I'm going to do one from the wizard level. So in this case, one of these does not belong. So this shows I've got a positive velocity, but it's getting slower and slower. This shows a negative velocity going faster and faster. This shows I'm moving to the right, so that's a positive velocity, slower and slower. This, with a force to the left, could agree with these two. It would not agree with a negative. Oh, could agree with that, but I think this is the wrong one. So that's sneaky. So this one is not like the other three. These three can be consistent with each other. This one is not consistent with these two. This one could be consistent with this, but it's definitely not with the other two. So I'm going to pick this one. Again, I think that's sneaky. I'll do one more here in the wizard level. So one of these is not like the others. So this shows an object with a negative velocity getting slower and slower. This would not agree, so these two do not agree, because if this is a negative velocity, it's going faster and faster. This shows a negative velocity getting slower and slower. This shows a negative velocity getting slower and slower. So this would either show a negative velocity getting faster or a positive velocity getting slower, so that is not correct. All right, so those are some examples. Hopefully those help you if you have questions on them and are able to complete them in class.